Okay, the next thing that we're going to do is called standard form, which is kind of a misnomer. It looks like this. You would think that we use it regularly with the word standard form, but of the three forms that we've done, point slope form, slope intercept form, and standard form, it's the one that we probably use the least. You see here, x's and y's are on the same side in standard form, and it equals some constant on the right. Now, what it does is, like, we could graph this thing here if we solve this for y and change it to slope-intercept form. What standard form leads to, though, it leads to this thing called a cover-up method. And let me talk about that here for a second. So remember, every x-intercept in the world, an x-intercept is where the line crosses the x-axis. Any point on the x-axis has a y value of 0. Okay? And the y-intercept would be where the line crosses the y-axis. And of course, all of the y-intercepts in the world have what do they have in common? They have in common the fact that the x value is 0. Okay, so watch what I do here. To find the x-intercept, if the y is 0, I could essentially take this 0, plug it in here, and 0 times anything is 0. So this goes away. You can kind of like cover it up. And then just ask yourself, 3 times what is 15? Well, 3 times 5. That would be the x-intercept. The y-intercept, you just do the opposite. You see, the y-intercept, the x is 0, so if you plug 0 in here, that goes away, that gets covered up. 5 times what is 15? 5 times 3. And now you just go to these 2 points. There's the y-intercept. There's the x-intercept. And you just connect them. So it's just a different technique. Okay? But remember, what do all x-intercepts have in common? X-intercepts have in common a y of 0, y-intercepts of x is 0. Now here you got to be careful because this sign's negative. You got to pay attention to that. If this is 0, that's y, that goes away. 5 times what is negative 10? It's negative 2. If this is 0, that gets covered up. 2 times what is negative 10? 2 times, whoops, 2 times negative 5. Okay. There you go. Whoops, I got to graph that, right? Negative 2 comma 0. 1, 2, 3, 4, 5. There's the negative 5, and there is our line. Okay. So same thing down here. It's nothing different. You just got to be careful with the signs. X-intercept, remember that's like that. See, we can set this up. X-intercept, that goes away. That's going to be 4. Now you do the same thing down here. Y-intercept, this goes away. Negative 6 times what is 12? Negative 2. Okay. There's the intercepts. Okay. X-intercept, cover up 8 times what is 8? That's 1. And then the y-intercept, put the 0 in here. Negative 2 times what is 8? It's negative 4. There you go. So it's just a different technique. You know, instead of solving the equation for y and doing it in slope-intercept form, you can just do it with x and y intercepts. Now here, graph the following. Now here, this is kind of review. This is in slope-intercept form. So there's the y-intercept, negative 6, right there. And the slope says negative 1, so down 1 over 2. Now this is in a nothing form. So when you have a nothing form, usually we want to solve for y. We want to change it into slope-intercept form. So we want to get y by itself. Now most people like it when the y is on the left, so I'm going to move it to the left, and I'm going to put this other stuff on the right. It's the same thing. It doesn't matter what side y has to be on. Remember, I'm not done yet. I got divide by 5. Now I want you to realize this one's a little bit uglier because my y-intercept is a fraction. You know, negative 2 over 5 is like negative 0.4. So we got to just kind of estimate, you know, negative 0.4 is going to be about right there. Now we still go up 1, 2, 3 over 1, 2, 3, 4, 5. You're always going to be kind of in that in-between zone. So sometimes, you know, you're not always going to have a nice, clean y-intercept every time. All right. Now this is old stuff too. You know, if you wanted to change, this is in standard form. You know, we could graph it and find the intercepts, but you know, don't forget that solving for y and changing it to slope-intercept form works as well. So I could move. We just want to get y by itself. There you go. Of course, this y-intercept would be 6. The slope would be down 3 over 5. Here we have to move this over. Now this one's a little bit ugly too. Remember, that's a fraction, so our slope is 1/3. And here, you know, you get an ugly y-intercept. That's like 2.16 if you divide it on a calculator. But sometimes you get y-intercepts that aren't going to be so beautiful. Just so you know, okay?